Hello there, welcome back to Chentu.org. A while ago, I created this 4th of July fireworks using Excel, and quite a few of you are interested in knowing how this workbook is constructed. So I thought I'll make a small video explaining the basic process behind this animated fireworks Excel chart. So before we do that, let's just have a quick demonstration of the fireworks. So that you can understand what we are trying to build here. Okay, so here we are inside the original fireworks workbook. I have just moved the fireworks button to the top, so it's easy to kind of navigate it. Okay, so let me just click on the start fireworks button and see what happens. So when you click the fireworks button, it creates an impression of fireworks by shooting fireworks into the sky. So you can see a line and a circle of spokes basically drawn, and this happens for 10 times. So it's basically 10 fireworks shooting into the sky, and then at the end you see this "Have fun 4th of July" message. Now there are a bunch of things that are going on here, but the most important and the crucial part is the actual fireworks. So everything else that you see, the Lincoln Memorial image and the "Have fun 4th of July" this thing, that's just a text box, and the start fireworks is again a shape that was formatted to look like a button. When you click on it, it kind of triggers a macro in the background that would animate the chart. But the basic ingredient of this entire thing is the actual firework. So in order to understand this, let's just take a look at the ingredients. The first ingredient obviously is the chart that creates this behavior of firework. The chart itself contains two parts. First part is the line that is going upwards from behind the Lincoln Memorial, and the second one is the shooting star kind of image, which is the firework that you are seeing, which is nothing but a spoke drawn with a bunch of lines. So let me just demonstrate this once again, so you can see that this is just a line going up, and then there are spokes, a line going up, and then spokes, line going up, and then spokes, and the spokes are also increasing in size. So they start from 0 and then they go all the way up to a random size. So that's the first main ingredient, the chart. The second main ingredient is the layer of the Lincoln Memorial. So in fact, the fireworks are all starting from the same point in the background, but because we are putting a Lincoln Memorial image in the front, it acts like a mask. So anything that happens behind it, you don't see it. So it appears like the fireworks are shooting from behind the Lincoln Memorial. And then the last one is the third part is the message that you're seeing, "Have a fun 4th of July." And the fourth ingredient is the macro that animates everything. So we will go into all of them one by one, but the main part would be the chart. So let us understand how that shooting fireworks illusion is created. So to help us understand how the chart is constructed, I have created a smaller demo workbook. This is called as a single firework demo, and I'm going to walk you through that process. Okay. Before we actually go through the calculations, let us understand the math behind fireworks. Now, most of us who have studied physics back in school would remember some of the basic fundamentals of projectiles. Projectile is nothing but something that you are throwing into the air. Either you are throwing or thrown into the air by means of some sort of a force. Okay, so let us imagine instead of a firework, let's imagine you have a stone in your hand and you are throwing it into the air. Now the natural trajectory, that is the natural path that this stone would take up is called as a parabola. Now again, explaining what a parabola is, For those of you who have forgotten what it is or who have never learned what it is a little tricky. But this is how it looks like. Let me just fire up my my pen, and so if this is if you are standing here and that's the stone and you're throwing it into the air, a natural path of the stone would be something like that. It's a very loose illustration, but you get the picture. Okay, so that's the natural path of a stone throw. Now the same thing will happen when you light up a firework and it goes into the sky. So it would be a parabola, but it won't be like a stone thrown. It won't be like that. It would be more steeper. So it would be something that goes up all the way into the air before falling. Now the actual trajectory of a firework won't be exactly a parabola. This is because there are other forces coming into the picture. When you light up the firework, it has some ammunition, very light ammunition that kind of kicks the firework up into the sky. The initial trajectory would obviously be a parabola, but because it's a firework, it has many other things going on, right? So the firework also has some other explosive inside it that would create the reaction of stars. So when that happens, when the firework actually blows up, so the firework has two things. One is a small payload, something like a rocket, that would kind of take it up into the sky, and the second one is the actual explosion. When the explosion happens, that would impact the trajectory of the firework. So it won't be a parabola anymore. It would be a mixture of a couple of parabolas. So why I am telling you all of this is just to give you an impression of how complex this calculation can be if I want to mimic the firework behavior in a realistic way. Okay. The second aspect that I want to bring to your notice is see how straight line like the initial trajectory is. Before the explosion happens, the firework is pretty much going like a straight line. May not be at a 90-degree angle. If this is the horizontal plane from which the firework leaves, the degrees of angle between these two won't be exactly 90 degrees, but it's pretty close to 90. We could say something like it would be between 80 to 120, okay, or even 85 to 10 or 115, right? Something. So it's a very close vertical. And when the firework leaves, it goes almost in a straight line until the explosion happens. And once the explosion happens, it would change its trajectory and it will fall back to Earth, whatever remaining part is. So the things that we can understand is the actual trajectory of firework depends on two forces: the payload and the explosion. And the trajectory almost looks like a straight line. So I'm telling you all this because mimicking this exact path in Excel can be a little complicated, but we can take a shortcut. We can instead use a straight line because until the explosion, the firework looks like it is going in a straight line at certain degrees of angle to Earth. Okay. So instead of figuring out the entire logic of a parabola and mimicking those things, we could just draw a straight line and that itself is good enough for us. It's a pretty good approximation of how a firework would fly into the sky. Okay, but those of you who are a little more curious to understand the physics behind it, that's why I kind of went and explained that. Let me clear this up so we could go and draw once again. Okay, so that part is the trajectory part. So instead of doing the entire parabola thing, now we have decided that we are going to do it as a straight line. When we want to do it as a straight line, there are two things that come into picture. The first one is there are two parameters when we want to consider it as a straight line. What is the degrees? let's call this as theta. Okay, again I'm trying to sound mathematical here, but this is nothing but the angle at which the straight line is moving away from Earth. So imagine this is the straight line. This is a straight line. Obviously this is not a straight line, it is slightly inclined, but just for the second there, imagine that this is the straight line, the top one, and fireworks are lit here. So one firework may go at exactly 90 degrees, but there are a few that will go like this, like that, like this, or like that. So this angle between that line and the horizontal line is what I'm calling as theta. Okay, this one is theta, and that's the parameter number one. We need to figure out what angle would be used for flying this firework. The second parameter is the max height. So this one is nothing but height, to which height the firework will reach. So these two are nothing but the parameters that define how high the firework would go up in the sky, and at what point of the sky it will lit up. Okay, so if it is a 90 degrees and 100 feet high, then it will probably be somewhere like this. Okay, if it is 85 degrees and 75 feet high, then it will be somewhere here. So you get the picture, right? How high the firework goes and what degrees it will go. So these are the two parameters that kind of determine how our firework would behave. So we have theta and we have height. Now let's go ahead and plug these two variables into a simple equation. So imagine the firework is lit up at the initial location, the origin of firework. Let us call this as x and y, the initial coordinates of the firework, and the final coordinates of the firework would be x1, y1. Okay, so we have initial, we have final coordinates, and we have a line that's drawn. The length of this line is nothing but height, h, and this is the, oops, that's not the one. Let me just clear the screen once again. This time I'm going to use drawing in Excel so that we can preserve this drawing. So we have a straight line. Drawing a straight line on this slate device is so much more difficult. So we have a straight line and we have the initial point of origin. This one we are calling as x, y. So this is where the firework would be lit up, and it goes up all the way into the sky to a random location called x1, y1. And if we draw a line between these two, again drawing lines on this thing is slightly tricky. That line has the length of h and it has theta. It has theta degrees between the horizontal line and that's it. So this is how the firework would look like. Not the bottom one. Bottom one is just the surface. This is the trajectory of the firework before it explodes here. Okay. Now, in order to mimic the behavior that the firework is actually going from here to there, what we need to be drawing a line that is kind of growing in height until it reaches x1, y1. So we know the starting point of the line. The starting point of the line is x, y. Okay. This is a random location. We can just select a random x and random y, and that is where the firework is lit up. So calculating initial location is very simple. It's just random values. Calculating height and theta is also simple because they are random values. What we need is the final points, x1 and y1. And this is where a little bit of trigonometry will come in handy. I'm not going to go into the details. Instead, I'm going to leave that to your imagination. But the basic approach is like this: height multiplied by sine 90 minus theta. Likewise, height multiplied by cos 90 minus theta. Okay, so this is the basic formula for the endpoints x1 and y1. So if we know x and y, x1 and y1 would be that. Obviously, this is not the exact formula. This formula assumes x and y are 0. If x and y are not 0, then we have to add x, add y to it. Okay. So this is the basic approach for calculating the endpoint. So if I want to calculate somewhere in the middle, okay, at this middle point the height would be h1, let us say. That point would be nothing but h1 multiplied by sine 90 minus theta plus x, y1 multiplied y1 is equal to h1 multiplied by cos 90 minus theta plus y. So wherever h is there, we just replace h with h1. So all we now have to do is to create the impression that the firework is going from here to there. We already know everything in this equation, so the only variable will be h. So we take h and we increment it from 0 to h. Okay, so we step through each and every value of h until we reach the maximum height, and at every point, if you keep drawing the chart, it looks like the line is going from this point to that point. Okay, enough drawings here. Let's just jump into Excel and see how this whole thing would look like. So I have a simplified firework demo. The first part is the line part. So for your convenience, I have plugged in all the values. The line part is starting location, origins are 10 and 0. So y-axis is 0. That means the firework is starting at the ground, and x-axis starts at an arbitrary location of 10. These are input values, so you can change them. We plugged them at 10. And the theta, the angle at which the firework leaves ground, is 85 degrees. Again, this is a random value. I choose 85. You could put 80 or 95 or 92 or 101, whatever you are convenient. And we have assumed that the maximum height this firework will reach would be 100. Okay, so it's going all the way up to 100. And then we have current height percentage and current height. We are not doing anything with them as of now. And I have put a dotted line to show the trajectory that should be taken. So far the firework has not been lit, so it's not going anywhere. So it is still at 0 location. Now if I change this to 10, you can see that the firework is going from here to there. Likewise, if I change this to 25, it's going there. 50, it goes midway. 100, it goes all the way to the top. So this is nothing but the impression of firework going up. Now what we are doing is we are typing the values here. Instead, if we could write a macro that would change this cell value from 0 to 100, from 0 to the maximum height value, then our job is done. We simply have to run that macro, and this line will go from here to there. Let me just show that macro. When we are writing it through a macro, since the height can be a random number, instead of changing the actual value, we can just change the percentage. So it will appear like we are incrementing by 1 percentage point at a time. So what we will do is we will write a formula here that says that much percentage of maximum height. And we take the percentage cell. This is the one that we will be controlling through the macro. And I'm going to turn on the formula bar. And we are going to give this a name. This is currently C10 cell. Instead, we are going to call as PCT height, a short for percentage of height. Okay, remember that name because that is the one that we will be using in the macro. And let's go to view code. I'm going to just resize this so it fits into the recording area. Okay, and this will be a very simple macro. First, let us insert a module, and let's call this as sub animate. Okay, so this is the macro that we need. It's a very simple one-line macro, if you will. It's not really one line, but there are a couple of lines. But it's a really simple one. All we are doing is we are asking, we are setting up a variable called temp val for temporary value, and it's an integer, and we are running it from 0 to 100. So for each of temp values from 0 to 100, we are setting the percentage height to be temp value by 100. Because it's a percentage, we have to pass on as a fraction. So we are just taking the temp value and we are dividing it by 100 and passing it there. After setting that, we are asking Excel to do events. Do event means go ahead and update the charts or something like that. Okay. So once this is done, once you run this thing will go from here to there. Now I'm going to move it here and let's run this macro. And you can see this line is going all the way there. So it's a very simple macro. This is not the exact macro that we are using in our firework, because this one actually is quite slow if you observe. It's really slow. It appears like the firework is taking ages to reach sky. So what I have done is I have used a stepping increment so that we don't draw this for every percentage. Instead we draw it for every 5 percentage points. Again, that thing is irrelevant for our understanding of how this works. So this is how the firework shooting part goes. So from here, the firework reaches the sky. Now we need to explode it. Let's unhide the second part. Before we talk about the calculations for that, let us quickly understand the logic behind explosion as well. So again, time for us to do a little bit of drawing. Now, the thing to understand when it comes to explosion is, again, there are many ways the explosion can happen. I choose the easiest one. I assume that the explosion, when it occurs, it creates a star impression. Okay, so we're going to get the firework explosion would look like a star. In real life, when you lit up the firework and look at the exact shape of the firework explosion, it won't be exactly like a spokes like this. It would be something different. It would probably be, these won't be straight lines, these would be little curves like that, and there will be more curves for the downside and up, not upward. So a real explosion would look more like this. Okay, so it's as if an octopus or a spider or something like that. It will not look like exactly like this, but it will look like that. Again, for the sake of simplicity and convenience, I chose this because it's not really gonna matter that much. So we have a bunch of spokes, and the impression of explosion is created by increasing their lengths progressively. So the first thing that we need to figure out is how to draw a set of spokes like this. We can draw a set of spokes like this in many ways. The easiest would be, imagine the origin. The origin of explosion would be nothing but x1 comma y1. Remember, x1 comma y1 is the final point of our firework. So from here it went all the way there. So explosion will occur only there, and that will be the origin. So the origin of our firework could be x1 comma y1. So that's the center point, and from here we are going to from here we need to draw the lines. So one option would be, first let's assume how many lines we are going to draw. For the sake of our fireworks, I assume that we are going to draw 40 lines. Okay, so 40 spokes are there. So from x1 to y1, we just calculate all these 40 points along the circle and draw them. So we have 40 lines. Now to draw 40 lines using scatter plot of Excel, we need 40 series of data. So that means series 1 will have x1, y1 and that point as the data. Series of 2 will have x1, y1 and that point as the data. Now there is nothing wrong with 40 series of data, but since we want to explode 10 fireworks, this means the chart will have 10 multiplied by 40, 400 sets of data passed on. So the chart will have 400 series of data, and although again we can use VBA macros to load that, Excel has several limitations, and loading that many series of data to a chart is probably not possible. This is because I remember Excel has a limitation of 255 series of data, but I'm not really sure whether that's true with Excel 2013 or not. It used to be 255 series of data. The second main reason is if you put so many series of data in a chart, the chart will be really slow. So your animation won't be smooth. So we need something a little more elegant than that. That answer came to me thanks to inspiration from Roberto, who participated in our Excel dashboard contest recently and shared his solution. So his solution contained the answer for this particular problem. So instead of drawing 40 lines, what if we draw one line that can give us the shape of a spoke? Well, you might be thinking, hey, there is no one equation that can generate the spoke kind of curve, but there is one trick. So instead of drawing 40 different lines, what if we draw one big line that has this shape? So it starts from x1, y1, that's x1, y1, and then it goes to the first point of it draws the first spoke. So let us call this as C1, CX1 and CY1. Okay, circle x1, circle y1. So it goes to the first spoke, and then we draw the third point of the chart would be same x1, y1. So that means we are drawing the same line twice, once going that way, once coming back this way. Since these lines are drawn one on top of another, Excel will make them look like a single line. So we started x1, y1, we went to cx1, cy1, then we came back to x1, y1. Now we draw one more line to cx2, cy2. Then we come back, draw one more, cx3, cy3. So like this, to draw the 40 spoked circle, we need 80 points. Okay, we need 80 points. Now this logic of using 80 different x and y points to draw 40 spoked circle might be somewhat tricky, and if you don't understand it, don't sweat it too much. You can explore the calculations in the attached workbook so that it might make sense. Otherwise, don't worry too much, because you know the basic logic, which is to set up a 40 series chart. This is just kind of making it smooth and easy for us. So let's go back here and unhide the calculations. So what I have done is, the first one is this. I have calculated all the 40 sine thetas and cos thetas, because we require that many different things and we don't want to calculate them every now and then. So I have kind of pre-calculated them here by first taking the degrees and then converting them to radians and then using sine theta and cos theta. Now in simple maths back in school days, we would write something like sine 45 or cos 45, and that's okay. But in Excel, you have to pass the degrees as radians, so that's why we convert them degrees to radians first and then pass them on to the formulas. And then the second thing that I have assumed is size of the spoke. So we assumed that the size of the spoke is 25. That's the maximum size to which the explosion can reach. And these are nothing but our endpoints. So if you see this is nothing but a reference to that endpoint, and this is a reference to that endpoint. So x1 and y1, these two are. And then we have 80 points here. All we did is, first one would be same as, first one would be 0, first coordinates are 0, second ones are calculated, third ones are 0, fourth ones are calculated. So this means we are just simply alternating. So we are going from origin 0, 0 to a location and then coming back to 0, 0, going to another location, coming back, going to another location, coming back. Again, as I said, this calculation might be somewhat tricky to understand. And here so far we are not using x1, y1 values. We are just assuming the fireworks are exploding at the origin 0, 0. So once we have done that, let us just select this entire 80 row data and insert a chart, and we get, so this is a single series of data and we get this nice spokes image. So this is nothing but your firework explosion. So if we could now place this explosion on top of our original data, original line, then our job is done. How do we do that? Well, the first thing that we need to do is we need to add up x1 and y1 values. So I select that and make it absolute. And fill down. Once that part is done, we have the new data, and select this and go to select data of this one and add spokes. These are the x values. And these are the y values. So let's click OK. Let me save this as a macro enabled workbook. And so here you can see that the explosion is happening. We can only see a part of it because I have fixed the axis of this from 0 to 100 and this one from 0 to 100. So let me just change that. This one would be minus 50 to 150, and this one is going to be 0 to 150. Okay. Now let us select the spokes and let's just format them so they don't look so thick. I'm going to adjust the weight, and that's just going to do the trick. Okay. So here you can see the spokes and fireworks. So this is how a single firework is constructed. So then once you understand this logic, everything else is easy. All we did is we repeated this process for 10 times so that you get 10 different fireworks. The only remaining part of this puzzle is how did the explosion occur? Here we are seeing the entire firework at once, but in the original firework, what happens is we are seeing as if the spokes are increasing in the size. How does that happen? Well, it's no mystery. All we are doing is adjusting the spoke size again through a VBA macro. So let's go back here and do the same. This is 25 and I'm going to put 25 here and 0% here and calculate this as that much percentage of this. So initially there is no explosion, and if I change it to 5% we see a small explosion, 25% we see a bigger explosion, 50% we see even big, 75%, 100%. So this is how the explosion action occurs, and we control this variable through our VBA code. Again, we can just say this as PCP spoke. So that's the percentage of spoke, and we can go to our VBA code, and here we could add one more line that kind of animates the spoke. So I have added that logic, which is another for loop to animate the percentage spoke, and now let us just see what happens. See this as I run this VBA. Okay. So you could see that it was not very smooth. This is because we are stepping through each and every value of our percentages. If we fine tune this, for example, step 5 and step 4, this also 5. So this would kind of make it appear smooth and fast. Okay, so you can see that the explosion is also rapid. Or we could reduce this to 4 or 2 so that there is a difference between the speed of going into the sky and the speed of explosion. So this is how a single firework is constructed, and then we repeat this process 10 times to get the 10 fireworks. Let me just jump into the original file so I can show you the calculations. So here is the sine and cos calculations for all the 40 different spokes, and we have tracker coordinates. This is nothing but individual fireworks. Because we have 10, I used the C1, C2, C3, C4 like that, and their X and Y locations. Now every time you run the fireworks lit up at different parts in the sky, and also they start from different parts on the ground. This happens through this randomization exercise here. Here we are using random formula. But we cannot use the random formula here directly. This is because what happens is, if this is random, every time we are running the VBA code and change a value like the percentage value here, and come back to Excel and say do events, this random value will be recalculated. So this firework won't appear consistent. So what I have done is, at the start of the firework, when you hit the button, I am loading current set of random values here. So these values are copied and pasted here, so that we start that iteration with a fresh set of random values. Those values will remain the same because here we are pasting them as values. And when you hit the firework button once again, one more set of random values are copied from here and pasted there. So these are the random X coordinates and these are the Y coordinates. Y coordinate will always be 0 because we want to start the firework from ground. And these are the angles at which the firework goes into the sky, and this is the maximum height to which the firework reaches. And we calculate the last points, and we use VBA code to animate the current position percentage. So from 0 it will go up to 0, 1, 2, 3, 4, 5 all the way to 100. And then once C1 reaches sky, then we explode it. So current size is set to 0, and then it will go from 0 to 100. So after this, we work on C2, explode it, and disappear C1 by resetting the values to 0, 0. So this way, you only see one firework in the sky at a time, and that impression is created. So these are the calculations for the spokes. Each one has 80 points. And again, this might look a little boring and laborious, but all it is doing is repeating that process for 10 times. Okay. Now let us examine a little bit about this particular setup. How we created a frame here of making it appear like the fireworks are coming from behind the Lincoln Memorial Building. That is by first what I have done is I have downloaded an image of Lincoln Memorial. Well, not downloaded. I purchased it from one of the freelance photography websites. And after getting that image, what I did is I created two images. These are the two images. What I did is, this is the original image that I purchased. This is the memorial front image. So this one contains only the front building portion of the memorial, none of the background. So then what I did is I put the memorial image in the background and put the chart, and then on top of the chart I put the front portion. The front portion contains only that much image, everything else is transparent. So what happens is this little building alone is overlapping the chart, but none of the sky part. So when the chart starts drawing the line, an initial few feet of the line are hidden away by the building, and then the building is no longer visible because this portion is transparent. So that line kind of appears like it is starting from that part of the memorial building or this part of the memorial building. So that is how we created a mask so that we can get that impression. You can examine the code of this particular one. It contains a couple of macros for resetting and showing and hiding the message and all that. Just examine it. It's not too tricky or difficult to understand, and you will be able to make sense of it. So that's how the fireworks are constructed. I know it's a longish video, but I hope you have enjoyed it. Thank you so much once again for tuning into Chandu.org YouTube channel and listening to this video. I hope you have enjoyed it. And if you like this, please drop us a note or a comment or hit like on our video so that more people can discover it. Thank you so much, and you have a great day. Bye-bye.